Hello, everybody. My name is Rod Soto, and this is a presentation that I given already at Hack Miami. Unfortunately, we weren't able to record it, and because we weren't able to record it, I am recording it after it happened. So this is gonna go on YouTube, and hopefully, those of you who weren't able to participate can watch it if you have time, can criticize it, collaborate, or even make it better. So let's get started. Um, Today, I'm going to talk to you about Langchain. So Langchain is basically a framework based on Python that is used to interact, enhance, and extend large language models. Before we do that, we're going to do a little bit of um, a recap from a previous presentation that I also have. You can find it in my GitHub, where we talked about um, the basics of uh, prompt, what prompt engineering is. We even go into some cases of jailbreak, and we even go into some attack vectors against prompts. We're not going to do that today. Today, we're basically introducing Langchain. I'm going to close with a link to a related cybersecurity presentation that has been given at Hack Miami conference, and I'll tell you more about it in a little bit. So today, this was a presentation that was given on February 24th. I'm going to emphasize the date because one of the things that we're going to know about this technology is that it's very rapidly evolving, and many of the things, depending on when you're watching this video or were able to clone the repo, you will realize that most of the code has been either deprecated or probably is not even working code anymore. Uh, I can tell you personally that during the creation of this presentation, I went through around 3 to 4 books, and half of them already had examples that couldn't even work. And these examples could not work because simply um, the code has been updated, the code has been deprecated, and that's something that you need to be ready to adapt, and you need to be ready deal with as you interact with these technologies. So let's go ahead and get started. So most of you know who I am. I co-founded Hack Miami, co-founded Pacific Hackers. Right now, I'm dedicated to Hack Miami, and this year we will be featuring a lot of presentations. Some of them had to do with AI. We believe this is a technology that is upcoming and will be disrupted and changing the current landscape, not only of our careers, if you're a professional in cybersecurity, but the threat landscape. Of course, malicious actors are going to use this, and we need to learn the background of this technology, how to manage it, how to use it, and how to tackle with future challenges that are already here. So, sorry, let's recap pretty quick about LLMs, or large language models. Basically, a large language model is an advanced type of artificial intelligence that has been designed to understand, generate, and respond to human language. They're called large because they're trained on vast amounts of text. This text is usually tokenized for purposes of vectorizing the backend, processing a faster processing and indexing, and obviously subsequent analysis that will produce some sort of a response, and that will produce or generate some sort of a knowledge of or data that will come from these actual models. And as we have seen with the ChatGPT, this is something that has revolutionized many industries, including ours. And that's basically a large language model. Today, we'll be working mainly with um, OpenAI, which, in my opinion, right now, as of February 2024, is the leader. We are going to use GPT-4. We're going to also play with Hugging Face, and we're going to use other services which are part of the growing ecosystem of the AI economy, or the AI uh, um, uh, ecosystem of companies. So, what is also generative AI, which I already sort of uh, uh, defined, is a subset of artificial intelligence technologies that are capable of generating new content, be it text, images, music, or other forms of media. So here's some of the key aspects of AI. Remember, we're recapping. If you want a more like an entry level, that what are these things, you should go and download my prompt 101, prompt engineer 101, where we go over. We even show you how to these things are tokenized. We even show you what tokens means. We even go over the process of how these models were trained. But very quick, they use deep learning. They use several type of deep learning methodologies, including GANs, which is generative adversarial networks, variational autoencoders, transformer models like generative pre-trained transformer, or GPT. They use applications, and these applications include designing things, creating art. If you ever use DALL-E, for example, generating realistic human-like chatbots. That's one of their main strengths. You've probably seen that. And obviously, these things uh, at times and right now do have a quite a bit of a societal impact, which in some cases may be negative. We have seen cloning of voices that led to deep fake voicemails. Some of them have been used apparently in electoral political scenarios. Others of kidnapping, um, where the victim is basically clone the voice, and then a family member receives some sort of a voicemail of this person has been kidnapped. We're already seeing the effects of unfortunately, the bad of the use of generative AI. So let's get very quick on prompt engineering, which we already talked about it, but just to recap, I like this, specifically this definition. Is a comprehensive process of designing and optimizing specific and unambiguous prompts for a large language model to ensure that it generates relevant, accurate, and coherent responses. I like this definition from Emiliano Viotti, because it's very concise, specifically in the part of unambiguous prompts for large language models. There is at times the notion that these things are not smart enough. They may not be there in certain aspects, but it's also true that if you don't ask the right questions, and the questions obviously are asked by a prompt, if you don't craft those prompts correctly or in the more efficient manner, you're not going to get the right information back. And we were able to see that yesterday as we were playing and testing these things. So what you're going to see in this presentation, this recording, it's basically you're going to see the slides with the results of my prompt uh, that you can download in my GitHub repository. I will go over it so you can hopefully repeat and follow this presentation. And then obviously prompts usually contain instructions, examples, and inputs. We're going to see that as we go in this presentation. Here's something that I took from a book that you should buy because the book is amazing. It's called Generative AI with Langchain. You can find it in Amazon. Like I said before, I read around 3 to 4 books in the making of this presentation. Unfortunately, the majority of them or the code was already obsolete, so I was not able to really get much of it other than the conceptual part of it. So here's some of the prompt engineering techniques. Prompting is something that is right now, obviously, as this LLMs evolve, prompting is fundamental because that's how we can obtain, interact, and even extend the functionality of these large language models. It is my opinion that eventually the prompting part will be reduced because as they learn, they will even reduce to prompt themselves. So we won't even need to have prompts or necessarily be that skill in prompting. So this is sort of like a phase that we're going through. So here's some examples. You can look at my previous presentation if you want to see more of it. The zero shot, for example, is the classic. You go just don't provide an example, just ask the question. You have a few shot, for example, where you provide demos and input of the desired output, and you help. You will see some examples of this today. We had things. The one that usually is the that is mentioned a lot when you're getting hallucinations or wrong answers is the chain of thought. And in the chain of thought, basically, you prefix responses with intermediate reasoning steps in order to help the LLM respond. Right. Then you have a bunch of others. I've seen some that are very complicated and theoretical. Really don't want to get into the depth of the theoretical stuff here because that's not the purpose of this presentation. This presentation has been designed for people that basically has a little or few knowledge in coding and are trying to see what's happening behind uh, the execution of these large language models beyond the simple GUI or whatever you're presented. So you understand that one of the things I want you to take from this presentation is not to take the face value of these things. These things have been trained. The people that trains them are biased, and they can say it until the cows come home that they're not biased. They are biased. It's very clear, has been proven, and I will show you some examples of it. And also, one thing that I want you to take from this is that these tools, and you will see this as you see the execution of code, will be used by decision makers, first responders, physicians, military, law enforcement, academia, and you name it. We have tons of examples where the use of these things are going to come into play, and we need to be rational and critical of the knowledge produced from these things, which at times, I agree, it is very precise, it's augmented, it's even something that is a force multiplier depending on the context, but it can also be very wrong. And it can mislead and it can be used to ulterior malicious purposes. So let's go ahead and continue on this. Here are some of the current limitations of the LLMs. I repeat, this is February 2024. And I keep insisting on the date because since I started reading on this, which was months ago, things have changed rapidly. And a lot of the initial code that I was playing with it is basically gone. So this is something you need to consider when you're looking at this technology, especially if you're actually watching, who knows when, this presentation. Hopefully it will be within the time frame where you can use the code. So here's some of the things that you need to be aware of. One of them is outdated knowledge, right? Most of these LLMs rely on training data without external integration. They cannot produce recent real world information. I believe this is something that will be overcome soon. But right now, if you actually looked at OpenAI, they will tell you my training or my knowledge comes to this date. So from there on, I don't know. I can't respond about it. Also, there is inability to perform certain actions, right? So in many instances, these LLMs cannot perform searches, calculations, or lookups. Obviously, remember the part of the reason for this is because you want to narrow obviously the training so you get more efficient responses from your training data. Once you start introducing things where you allow, for example, the model to search the internet, for example, there is certainly the risk that there will be knowledge in there that will poison, right? Or the current knowledge or the responses of these LLMs, and you risk mistraining the model. That's one of the reasons. Uh, I'm sure this will be overcome soon, and I'm sure that soon the whole thing that they cannot interact will go away. Also, we have hallucination risks. Um, we know context of external integration. Basically, sometimes these things make stuff up. That's what MSU is. So we don't know. Then it has been said by many of the people behind this the great inventions. They sometimes they don't even have an idea of how these things come up with the answers they come up. Biases and discrimination. I just posted it right there, a screenshot. One thing that happened to me when I was basically researching for this presentation, where I was trying to generate a simple image with flowers, and I got that from Replicate. Replicate says, "Oh, this is not safe for work. Please try a different prompt." I wasn't even near not safe for work, but that tells you, right? That there are right now, and there are other examples. On OpenAI, for example, where there are guardrails, there are biases, and there are definitely predisposition elements that will somehow limit or block any type of answers, especially those who are sensitive, and I would say non-politically correct. I would say that there's a heavy uh, um, drive into not offending anybody. Obviously, this produces the bias model. I mean, we're trying to talk about training, right? Take away the morality of things. There's clear bias for certain reasons. Obviously, we want the to obtain the best and the most benevolent use of these things. So I'm not saying this is necessarily bad or completely flawed, but it's definitely there. And of course, there's lack of transparency. Many times we don't even know whether the criteria is set to evaluate these things. I know the European Union is actually trying to come up with a set of regulations that will show us how these algorithms were trained, how these models were trained. Obviously, I don't think the Americans are going to stand for that because that will be revealing the secret sauce. And obviously, that, that's sort of agree. We can just give it away, but that's certainly there. There is a lack of transparency. So here's an interesting, funny term that I found as I was reading and researching for this. The term stochastic parrot. An stochastic parrot is basically a large language model which answers, right, produces a somewhat or somehow convincing language. However, it in reality does lack of true comprehension and the meaning of words. And this is why I say be careful. Don't take the value of these things, the face value of these things without verifying them, because it may grammar wise, semantically wise, this may sound, but in reality they are just sort of putting it together according to the training they have. And I guess as a model, you're trying to get the best answer you can. That doesn't mean you understand it or have actual comprehension of what's behind it. And if we are into that scenario and we're presenting this to somebody that somehow thinks that this is true by default, we got problems, obviously. All right. So now let's get into Langchain. Langchain is a framework created in 2022 based on Python. Um, One of the things that Langchain helps us do is um, make this LLMs context aware via prompt instructions, a few short examples, searches from the internet, for example. We're going to see that. That's a super interesting reason. Also, we can help the model to come up with an answer based on the context, what actions to follow. And there's an entire ecosystem of this, which we will be able to see in just a few minutes. This ecosystem, again, February 2024. By the time you see this, it will be probably larger or it will be reduced. We don't know yet. This technology is evolving so fast that at times it's hard to predict. So here's some of the several parts that, as of now, we can identify on this framework. One of them is libraries. There are two versions. There's Python and there's JavaScript. I'm going to stick to the Python one because that's the language that I prefer to use. There are templates. These templates are deployable. They have references. You can download them. You're going to see the actual links in this presentation. There is a Langserve, which is a library for deploying Langchain as a REST API. There is Langsmith, which is also a platform that allows you to debug, test, evaluate, and monitor chains built on any LLM framework. We are going to use it at least in one instance. We're going to use a different model from Google. Actually, we're going to use Hugging Face for that, and that's the beauty of this. We can use the ecosystem of AI companies for Langchain to query them, right, and try to get our best answers, or just for an exercise of curiosity, which is to see what's going on, right? So here's some of the advantages. Obviously, the advantages obviously are many. We can integrate with LLMs. With the framework's modular design can be imported. You can choose what you want depending on what you want to do. You can use chain of thought prompting. Like I said, it's being mentioned like one of the mechanisms to improve and get more efficient and better knowledge from these LLMs. Easy to use. Not an expert in Python, but I was able to figure it out. I'm sure you can too. Uh, Obviously, there is a big community behind it. There's lots of collaboration. And also, there's lots of application development. It is definitely a flexible framework. So our goal today, or yesterday rather, was to interact with LLMs via Langchain. And the way we did that, basically, we're going to use two main engines. We're going to use Open AI API, which you're going to have to get, and you're going to have to pay. There's no way around that. And then Hugging Face, which you have to go through a process to get it to. And with that, we're going to use a client. The client's going to be your Python script. We're going to craft the prompt, which is going to be in the client, the code. And then from there, we're going to query the LLM via API. And then the parser, output parser is basically text that comes out in your either VX Code or Jupyter. Most of this is Python. There's a couple of Jupyter notebooks. Basically, one is for Wikipedia and one is for DuckDuckGo that you can use. They're super simple to use, but you can still use them if you basically clone my my repo. And there are other ways, obviously. There's scene parsers, there's flashy and GUI stuff like Streamlit, which I personally don't like. There's Landflow as well, which is a flow of Langchain where you can put the API. You can select visually. I want to add this prompt. I want to add this other elements, and then get an answer. Unfortunately, that did not work out for me. For some reason, I had a hard time, and a lot of the libraries were either outdated or giving me errors. So today we're not going to see any of that. Maybe we'll do a later presentation on Landflow as things evolve. Here's some of the tools that you can find with Langchains. Machine translator, calculator, maps, weather stocks, slides, table processing, knowledge graph, search engine, Wikipedia, online shopping. We're going to do several of these today, and you'll see the examples, and you can definitely expand on some of the code I gave you in the repo and basically try it yourself, which is the purpose of this presentation. So we can also, and we're going to do that today. You're going to see that. We did it yesterday, and it actually came out pretty good. It came out with an interesting hallucination that made us laugh. But I'll tell you more later. So basically, um, Langchain also helps you load documents, right? So we're talking basically PDFs. We're gonna do today. There's a script. It's called PDF Combo, and then you can import two PDFs. The two PDFs that I uploaded to the repo. One is the Neverending Story, which is one of my favorite books and movies. And then my favorite book all the time, The Divine Comedy by Dante Alighieri. So those are two books that you can import, and then you can ask questions about it. You can also load, just so you know, web pages and videos, and there is other data as well, which we're not covering today. We're just again interested in exploring it. Also, I wanted to tell you that there are other um, frameworks like Langchain. Basically, Microsoft AutoGen, which is the one that enables LLM applications using multiple agents that can converse with each other and solve tasks. And then you have Optimus Super AGI, which is with that name, it's an open source platform that provides infrastructure for building autonomous AI agents. And then you have Llama from Meta. So these are things that will be interesting to try and to look at too. But we're not going to look at them today. It is my opinion that Langchain is becoming the most popular framework to when it comes to interacting with LLMs. And then maybe later on we can talk more about the others. There's also, like I said, a GUI version of Langchain called Langflow, which I found very frustrating to use, and we're not going to see today. So here's how we get started. We're gonna you can go into this link and see the installation, which is basically those commands that you're seeing there. You can also clone my repository. You had to if you want to follow this presentation. And then obviously there is a number of requirements. I suggest you that that you create an environment either with poetry or virtual M, depends of what your flavor of virtual environments is, and install the requirements, and then just follow this. It's simple. You're just gonna have to add your AI, OpenAI keys, Hugging Face keys, Tavilla search keys, and replicate keys. So once you do that, you'll be able to get results pretty quick. So let's move on. Here are the very simple article, how to obtain OpenAI API keys. So obviously you can follow this presentation and use it in your IDE, which in my case, and you will see here is VS Code. There's also Jupyter, which you can use it. Most of this can be replicated on both. You have to obtain again your API keys, and I wrote the scripts or modified it in a way where it's easy to basically cut and paste. Obviously, you shouldn't put the scripts like that on GitHub. I got a warning that I try to check as much as I could before I posted them so they wouldn't leak any API keys. Um, and you can use things such as .env, or you can do a config a config file, right? And then store your keys there, and then import it. I know people are gonna look at the code and say, "Hey, how can you do this like this?" I did that on purpose because I wanted this to be easy. I wanted this to be an intro to many people that just started learning Python, and it was a simple way to get started. So what we're gonna do, if you're following this presentation, is you're gonna clone the repo, the start requirements, and then we're just gonna open the files and execute them, modify them as we go. And then, like we did yesterday, we sort of commented back and forth about the answers, and so if there was any differences in the responses, So, for example, we have this is sort of what I included in the repo so for you to try it individually. You have simple LLM prompts using OpenAI, Hugging Face, Replicate, and there's one with agents on the internet that is done with Divinity Search. Then there's several examples of prompt templates. Then there are Langchain chains. You will see it in one of the files. The files are usually named as repeating here. The agent in the internet. You can see you're going to execute it. You can see how it actually absorbs or tries to process what it's getting on the internet, and then it gives you an answer. Then we're going to import a PDF book, and you can ask questions about it. Um, you're going to have also other Python files where you can execute several prompts techniques, and then we're going to do a simple one. Sorry, with replicate. With replicate, unfortunately, I was not able to do it through Langchain because I had a lot of issues with the library. But we will generate a simple example so you can see how we can generate from a prompt, we can generate an image. And then you have a couple of Jupyter notebooks, which is the one for DuckDuckGo and Wikipedia. All right. So we would plug directly into the LLMs. If you want to, for example, when you get to the part of Hugging Face, here's a list of pretty extensive models that you can use. And that's why I like Hugging Face, because Hugging Face gives you alternatives. And as you can see, there's tons of models that you can use, right? From a simple Python script and Langchain. And then here's the power of Langchain. So as you can see, they're even tagged. If you look at your left, and you will see tons of them from text classification, token classification, serial shot, text to image, etc., etc. So this was part also of something I wanted to show, so you can just understand how fluid and diverse this is right now. Obviously, is the market is up for grabs. We know there's obviously a company that is leading the pack, but there are other things that we can try, and some of these things are actually pretty good. So continuing, here's some of the templates. The templates, let me actually open this link so you can see it. In this link, you will find popular templates that you can download. You can take a look at it. You can see the use of these templates, and you can obviously retrieve them, look at the code, and implement it yourself. So continuing here, let's continue. We're gonna play with chains and Langchain models. Chains refers to sequences of calls, whether to an LLM or a tool or a data processing step. And there is actually a file where you're gonna be able to do that. Here's also a chains module that I use. That's the one that we have right there. When you look at it, this is what I took it from. Or it got inspired from. Sorry, because I had to use Pinecone and I had issues with the API, so I ended up not using Pinecone. Pinecone is an interesting company that has vector databases. Vector databases are precisely that, a database of vectors. And what they do is that they improve the execution on the LLM because what they have is this big, very large backend databases of vectors that information is already vectorized, so it's easier to process and it's easier and it is more efficient when you're trying to execute this type of models. Here's another important thing that you want to see as you test the agents of the internet. Remember when we looked at the limitations of the LLMs? One of them was they were closed, obviously, for reasons that I understand. Uh, Refinement of models, prevent contamination, prevent mistraining, for example. So in this case, we're going to use tabulate search in order to extend the context of this model. And then, as you can see there will be an action, there will be a reasoning, there will be a thought, and then eventually there will be a final answer. You will see this in the extra slide, and you will be able to see it yourself when you execute it. We're also going to do a memory conversation. And this memory conversation, basically, you provide a sort of a context, and then we ask several questions. I did it in a single type of subject. I did it about Star Wars. You will see it actually in the code. You can change this code again. This is for you to do whatever you want, and then you can see how the answers reason based on memory pieces of what this conversation that was presented to the LLM. Here's also a very good blog if you want to check it out. Trio thoughts. So trio thoughts, we're going to see trio thoughts as well, which is a technique that takes inspiration from the way humans evoke or solve complex reasoning tasks by trial and error. In this approach, basically, a solution is explored through a process that resembles a tree, and sometimes, or mainly, if effective, enables backtracking when is needed. So there is a trio font. There are two trio fonts uh, files that you can play with. And here's the great blog where the author goes through the rationale of using trio fonts. Trio fonts are becoming sort of one of the tools that you can use in order to get a better reasoning, to call it a certain way, from the LLMs in order to get the better answers. Then we're going to have, like you will see in the extra files, you're going to see other prompt techniques such as your shot, which is the simple one, prompt directly without examples. Few shot, you provide the LLM with a few demonstrations of desired output. Chain of thought, you provide the LLM with intermediate steps. Self-consistency, which basically picks up the most frequent answer from multiple responses. And then, obviously, we just talked about it, trio font, which is evaluates multiple responses, it generates an answer. All right, so here's, I'm just going to go through it. And hopefully, at this point, if you are still with me, you clone the repository and you got your API keys, and boom, we're here. We're going to start executing code. And then I didn't want to do this about theory or theoretical. If you want to study artificial intelligence, there's tons of books, there's great universities, there's YouTube, you name it. And I just want to get practical for those who want to see basically the meat and potatoes of what these things do behind the nice and flashy GUI. So here's, as you can see, there's a begin the pie, simple. You can see we're using OpenAI. The temperature is how much freedom you want to give the LLM to answer. And then, as you can see, I asked them a simple question. What was Hack Miami? And if we looked at the answer here, is pretty accurate. You can see I'm already getting 1 here. At one point when I had a lot of the stuff that I was already working, I didn't want to update because I was afraid I was going to break it anyway. So mind the warnings, but it did work. So here's the answer about Hack Miami. As you can see, it's I'm using GPT-4. That's the model I'm using with OpenAI. And that was a simple question. And it basically gave me the answer, although correction, it looks like it's using GPT 3.5 Turbo there. So I don't see it in the code, so most likely that's what it used to respond to this question. The answers may vary depending on what model you're using. So now we use Hugging Face. Hugging Face, basically, I just show you, it's like a market for LLMs, and you can basically use the API to call them. In this case, we are calling Google Flan-T5 base, which is a specific model. And I did a simple question. The question was, what is the capital of Germany? As you can see, the answer is Berlin. So the answer is obviously correct. Yesterday, we did more questions and actually answered correctly. We asked history questions, and this actually worked pretty good. So here's another example. If you go back to that page that I gave you, you can change that in the actual repo ID, right? And then you can basically experiment and play with it. Here's another basic prompt template, which I'm using OpenAI. And basically, I'm telling it the template write a story about content, prompt template, length 2 sentences. In this case, I told it, I need you to give me a story about the hometown of a legendary nuclear scientist, J. Robert Oppenheimer. And as you can see, that's the answer. Uh, Not much to say about this. It wasn't really much of a um, difficult question if you have the right knowledge. Here's the agency in the internet, which is one of them yesterday with the tons of questions to this. In this case, I wanted to be a little more pressing on something that may not be concrete. So I asked him about this thing that's going around with a jellyfish UAP. So if you look on the internet, I don't want to put the video here. There's a circulation of so-called jellyfish UAP, which is supposedly like video of a UAP in a military base. It looks very striking, to put it in a certain way. So I said, let me ask the LLM using we're going to use stability search, and then you can see how it actually goes, finds a news article. You can see it there, and then from the news article, there's a thought, and then and then right after the thought, there's an action, which in this case is the final answer, and then it tells you, well, this is my response to you, basically. We Yesterday we actually queried it in several different ways, and it was pretty concrete. We were not able to get an hallucination, which you would think by asking something that is really sort of a gravestone there, right? This could this be fake? Is this true? Is this a classified technology? Is this an extraterrestrial? You name it. There are many multiple uh, uh, possible explanations to this. However, you can see that by using the internet and by providing the context, by its search, it gave us a pretty good answer. Actually, gave us a pretty good answer. So this is very powerful, um, and I really invite you to try this and watch at the end the link of the cybersecurity presentation that was given in Hack Miami last year, where the Langchain was used to control Cobalt Strike agents. So here's another change, line change. So basically, as you can see it in the code on your left, we had to import it, right? The line chain. And basically we use first prompt. The first prompt is, can we time travel? Follow that is let's think step by step. Then we have another template where there's a question, uh, or there's the question is put in as a variable, and then we formulate the question, right? So if we're trying this model to respond step by step, now we look at the right. This was the actual uh, response from the model. We also use conversational buffer memory, conversational buffer window memory, which sort of keeps some of the information as it goes. And as you can see, there are several outline items that the model came up with, and again, it gives us a reasonable answer. Nothing crazy here, but it's a way, obviously, of elicit or retrieving information from these models. Here's the memory conversation. In this case, I asked three questions. One of them is Star Wars a good movie? Then, who's the main bad guy? And then finally, did Han Solo die, yes or no? And the answers were correct. It gives me a context, as you can see to the right. It gives me a context of what is Star Wars. You can also see that it gives me a context of I'm an AI. I don't have an opinion, an experience. It tells me that Darth Vader is the bad guy. He even gives me his real name, which is Anakin Skywalker. And it tells me, yes, Han Solo was killed, and by whom it was killed, which is was killed. Let me see. It didn't put it in this one, but yesterday it actually did tell me that it was killed by his son, which was Kylo Ren. Um, and you can see that there is there's some sort of a logical and well outlined answer to my questions. Here's a simple example. You can extend on this. Somebody asked me yesterday, can I use the internet and play with this? Absolutely. I just wanted to give you a simple template. You can see the actual model that we're using, which is we're using from replicate. You're going to need the replicate API key, and we're using stable diffusion. And what I did in the prompt was put Miami Beach. I wanted to make it easier for you to retrieve it. So I actually, if you looked at the actual uh, code, is basically out the PNG. So go to temp, out the PNG after you execute the prompt, and you'll find your image. So that makes it easy for you to basically test it. We played with this, and as soon as we got complicated, the results were not very good. We were getting like garbled stuff, and definitely things were not really. We were not really getting um, the answers that we're looking for. However, simple prompts like for Lauderdale, for example, we put for Lauderdale and they generate a nice image, or simple things. It's not a DALL-E, right? DALL-E is amazing, but you can play with it. Here's a trio fonts. Trio fonts, as you can see, there's several outlines of steps where instructions are given to the model, right? And you can read them there. For example, have a problem for each of the three proposed solutions, evaluate their potential, consider the pros and cons. In this case, I give it some sort of a context, initial effort needed, implementation difficulty, and potential solutions. I think we were talking about human colonization of Mars. That's sort of what I took this from a blog. I thought it was a pretty good example of getting an answer to something that I had no idea, but I could somewhat verify by reading it and then going to the internet or asking people and see if this makes any sense. And actually, as you can see, it's a pretty good answer. It's actually they didn't tell me things like you can fly to Mars right now, for example, or things that sound incredibly outlandish or unreal. It did give me some proposals that seem in appearance sound. Here's the other one, and one of the ones that just they took a little bit more of attention is the PDF combo. I name it PDF combo. Basically, I took this, I built a script from several other scripts that I found on the internet. As you can see here, basically I imported uh, the Divine Comedy, which is one of my favorite books. So I kind of knew what was written in the book, and so I could evaluate this thing was hallucinating. Yesterday, I also recommend you, if you actually are looking at the script, you can see that there is a folder that you're gonna have to create called store, and then there's a SQLite database in there. If you want to repeat it, I would suggest you to delete those files, so that way you can start fresh if you're importing another PDF. Um, and you will see that the results tend to be different. Like this one I got was not bad at all, but yesterday, for example, this thing said that book, it was similar to Benjamin Button. I don't know how it was able to associate those two together, but that's an example of a possible hallucination. In this case, as you can see, it gets me the right title, the 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 name of the author. It sort of gives you a brief on what the story is about. So not bad to get started. Obviously, these things will get better as we go. But that's definitely a good example. There are people already that are downloading PDFs. There's tons of sites on the internet where you can upload a PDF, and this model's already been trained. And basically, this will give you answers on it. Consider that for uh, cybersecurity reports, exports of ports, vulnerabilities, services, ports, and then there will be some sort of reasoning if you train this model, and it will might suggest like very good things to or actions that may improve, right, the way you operate. We're looking into trying to do that, but I'm positive somebody already did this, so we will get more into the use of this with cybersecurity tools as we move on. We just, again, we decided that this year was going to be the crawl, walk, run. So we're basically crawling and walking now, and then once we get to running, we will probably see more. We're going to use Nano GPT and other things that may allow us to get a little even further of what we're studying right now. Here's a few shot template. Yes, this should be an easy question for this. Flow division, which is the Python flow division, is a number of requested results. Um, Response, it says greater than the number of elements, index 3, updating number of results. And then finally, it parses the content. Floor division is a mathematical operation that returns the largest integer that is less than or equal to the division of two numbers. In Python, the floor division operator is denoted by two forward slashes. So this answer is correct. This should have, I didn't expect this to fail because it was a sort of a simple question, but you have it there. You can practice with this. Um, then chain of thought. In this chain of thought, I use a simple example of I had two flipper zeros. I lost one. Then my friend gave me two. How many flipper zeros do I have now? Um, if you look on the code, you see the instructions. There are two instructions, right? One is let's think step by step. And the second one, explain your reasoning step by step, and then state the answer. And then obviously you see the prompt. The prompt is question, the variable question, right? Plus COT instruction. And then as you can see, the answer is correct. This is usually one of the things that these things will give you like weird numbers, especially if you uh, um, phrase it or word it. There's tons of examples on the internet, and I actually have some in my last presentation. But as you can see here, the reasoning went well, and it came out with the right answer. Here's the trio font. The second, where I asked him about time traveling, and as you can see, there's a reasoning chain, there's a ranking chain, and then with all these instructions and context, um, I asked, give me three most possible current ways to achieve it and explain why. Obviously, it's not an easy question. I expected all kinds of craziness here to be printed. However, um, the stuff that is in there is not that crazy. I don't think it's crazy for the most part, and is basically as much as anybody that will be knowledgeable will be able to tell you. Obviously, we're not using this for production. It's a mere exercise of curiosity. So for us, this was fine. Here's the self-consistency, where, again, we provide context and instructions. And I can see there for each answer in solutions, count the number of times it occurs. Finally, choose the answer that occurs the most. And then we'll see it there. We'll see instructions and number of solutions, which I put 5. And then it says this was a question that I was like, I got it from the UAP uh, um, context of all this leak footage. So I said, okay, they keep mentioning this holographic principle. What is the holographic principle? So it says there, it's a principle and a concept of theoretical physics that suggests that the information contained within a three-dimensional volume can be represented on a two-dimensional surface. AKA, I'm here, I do this, and you see my shadow on the wall. So the shadow on the wall is basically like sort of an emulation of or representation of this context, holographical principle. Here are the two easy ones. Wikipedia and DuckDuckGo, we didn't even need. You download it and it does it. I have some issues with the way I was executing it. Again, my apologies. I'm not an expert Python coder. I got into this a year plus, or almost 2 years now, and I'm still learning. So right now we basically using this in order to research and investigate this wonder things. And as you can see here, we used Wikipedia. They found the president of Hack Miami, Langchain. It's right there. Even found where he works and where he lives. And also, as you can see here, it also did a I also did a retrieval of DuckDuckGo search, and the information is accurate. The information is actually accurate. Okay, and finally, I wanted to leave you with um, a link of a presentation done by Marcus Correa and Jonathan Echevarria from ReliaQuest, and they did an amazing presentation using AI through Langchain in order to and apply it with a very popular red team tool, which is called Strike. There's the link so you can watch it. This was a year ago. So these dudes are pioneers, and that was a very impressive presentation. I suggest you read it. Hopefully, as we move on in Hack Miami and we learn more about this technology, hopefully you'll be with us. We can come up with ways of using technology, especially to enhance defenses, which is something that I believe we're all going to need to do. And with that, I hope you enjoy this presentation. And if you have any questions, uh, please feel free to reach out to me. I put my links in the GitHub repository. Here are the references. Again, there's that book, Generative AI, Langchain Language, in Amazon. You should buy it. It's an amazing book. Some of the things are already starting to be outdated. Be careful when you buy these books or these courses because this stuff is going just fast. And by the time you try to code it, it won't even run. And this was actually one of the challenges of creating this presentation, the how fast these things are going. And at times you only depend on forums, on blogs, because there's really no formal ways of figuring this out other than hacking it. So here's the Python Langchain additional resources and tutorials. I suggest you go through it. Hugging Face, important. Watch that company. They're going somewhere. And then obviously most of the companies that I chose to have either APIs or references is because I do believe they are becoming some of the spots on this ecosystem. I wanted to have Gemini. Fortunately, the API is not open yet. I wanted to test Sora, but I can't access Sora either. Sorry, in case you wonder why I wasn't. This is going pretty fast, and at times there's no access for a few privileged. And good for them. Hopefully, we'll have it too soon. And I'll thank you very much for watching this presentation if you stayed to this point. And hopefully, I will see you some other time soon. Thank you.